For each scenario, identify the appropriate growth model that describes how it's changing. Okay, so the options here for each of these questions are linear growth. Let's talk about that one first. That'd be like if we started off with 10 rabbits and then it went up to 15, right? It's just adding 5, and then it went to 20, it added 5, and then it went to 25. It's just adding, so adding the same number every time. Adding or subtracting, if it's going down, adding or subtracting the same number every time. That's linear growth. Now there's another kind, and that's exponential. And that's not how you spell exponential. Exponential growth or decay. These can go down. So we could start at 10, and so this is multiplying by the same number every time. Like we could multiply by 1.50, and that's growing by 50%. So that'd be 15, which starts off the same as the last one, but then if you multiply by 1.50 again, it's 22.5. And if you do it again, it gets up to 33.75. So this is growing by, I'll bring it down here, growing by the same percent. Instead of the same number, it's the same percent. In this case, it's 50%. 50% growth. It went up by half, right? 10, half of 10 is 5. It went up by 5. And then half of 15, what's half of $15? $7.50. This went up by $7.50. That's why it's up to $22.50 now. And then half of that is, going to be something more than $10, $11.25, I guess. So that's why it went up. So it's growing by the same percentage every year. Or in linear growth, it's growing by the exact same number every year. Add 5, add 5. So exponential growth is multiplying. So we could say it two ways. We could say it's multiplying by the same number, or it's growing, or I already said it. I already said it right there. So I'll just, or you could say it that way. It's growing by the same percentage. To multiply by the same number is to grow by the same percentage, because you're multiplying by the number 1 plus or minus r. So let's go back to the questions. The number of new polio cases has been cut in half. Now what's cut in half? Well, that's, let me say, decreasing by 50%. Each year, isn't it? To cut something in half is to have it go down to half of what it was. It's decreasing by 50% each year. So again, if you grow or shrink by the same percentage, that's exponential. So this one would be exponential. It's exponential decay. It's going down instead of up, but it's still exponential. So if you change from time to time by the same percentage, up or down, that's exponential. Tuition is currently $2,000 a quarter, has been growing by 7%. That's the same percent. It's going up 7% a year. That also is exponential. Okay, let's try the next one. The number of arrests grew for several years, but now has been decreasing. That's just not clear. They grew by what? Decreasing by what? They're not being clear. This isn't neither. We don't know. We don't know if it's exponential. We don't know if it's a linear. We don't know what it is, because they're just not saying much. Okay, so now this last one, the amount of pollutants in the lake has been increasing by 4 milligrams per liter each year. That's the same number, isn't it? It's the same number every year. So that's linear growth. So there's the differences between linear growth or decay. If you go down, that's if you're subtracting the same number every time, that'd be decay. So adding or subtracting the same number every time, that's linear growth. multiplying by the same number every time, which is the same thing as growing or shrinking, decaying, by the same percentage. Those are two ways to say the same thing. If you multiply by 1 plus 0.50, meaning 1.50, if you multiply by 1.50, that's growing 50%. And that's what we did in this example. We multiplied by 1.50, which grows by 50%. It's growing by the same percentage every year, or shrinking. If you cut in half every year, then you're going down by 50% every year. So that's exponential.